Lesson 59, Solving Systems of Linear Equations by Substitution. The substitution method says to rearrange one of the equations so that it is in the form of y equals mx plus b or x equals my plus b. What they're saying here is that you need to get one of the equations with either x or y all by itself and everything else on the other side. Then it says substitute the expression for the variable in the other equation. Solve the resulting equation for the variable. Step 4 says to substitute the solution into the original equation and then write the values as an ordered pair, because we should remember from solving systems of equations by graphing that the solution to the system is the point that they meet, which is an ordered pair xy. Solve the system of equations by substitution. So step 1 said that we needed to get either x or y by itself on one side. So here I have y by itself and here I have y by itself. They've already set these up for me. What I'm going to do is, since y is equal to 2x minus 3, I'm going to take that expression and I'm going to plug it in for y in the other equation. So in this equation, instead of y, I'm going to put 2x minus 3 equals x plus 2. Well, now this is something that I should know, or that we should know, how to solve. Because to solve this, we know we're wanting to get x by itself. And to get x by itself, we have to have all the x's on the same side. So I'm going to start by subtracting this x from both sides of the equal sign. And remember, we always subtract or add to like terms. So I have them stacked under like terms. These cancel. 2x minus x gives me x. Minus 3 equals 2. To get x by itself now, I'm going to add that 3 to both sides. This will cancel, leaving me with x equals 5. Well, now that I know that x is equal to 5, I'm going to take that and I'm going to plug it into my original equation, which is right here. You can put it into whichever one you want. That one looks easiest to me, so I have y equals, instead of x, I'm going to put 5 plus 2, so y is equal to 7. So my solution has to be an ordered pair, which is going to be xy, x is 5, y is 7. Final answer. Solve the system of equations by substitution. Check your answer. So on this one, I have negative 5x plus y equals negative 7, and y equals negative 3x plus 1. I have to have one of them with either x or y all by itself, and I have y by itself right here. So what I'm going to do is the same thing I did before. I'm going to take the expression that y is equal to, and I'm going to plug it into y in the other equation. So I have negative 5x plus, instead of y, I'm going to put that whole expression, which is negative 3x plus 1. And that has to be equal to negative 7. Now, since this is a plus, when I distribute, it's not going to change my sign, so I have negative 5x minus 3x plus 1 equals a negative 7. So, now I need to combine like terms. My like terms are negative 5x minus 3x, which is going to give me a negative 8x plus 1 equals a negative 7. To get x by itself, I have to start by subtracting that 1 from both sides. So I have that negative 8x is equal to negative 8. To get x by itself, I will divide by negative 8 on both sides, leaving me with x is equal to 1. So now that I have this, I'm going to take it and I'm going to plug it into an original equation. I'm going to plug it in here. So I have y is equal to negative 3. Instead of x, I'm going to put 1 plus 1. So negative 3 times 1 is negative 3 plus 1, and that has to be equal to y. So y is equal to negative 2. So my solution to the system is going to be 1, negative 2. To check this, I can then plug them in. So on the first equation, I have negative 5. Instead of x, I'll put 1. Plus, instead of y, I'll put negative 2. Whoops. Equals negative 7. So negative 5 times 1 gives me negative 5 plus a negative gives me a negative, so minus 2 has to equal negative 7. Negative 5 minus 2 is negative 7, and negative 7 does equal negative 7. Same thing here. Instead of y, I'm going to plug in my negative 2. That has to be equal to negative 3. Instead of x, I'll put 1 plus 1. This gives me a negative 3 plus 1, which we say has to be equal to negative 2. Negative 2 is equal to negative 3 plus 1, which is negative 2. That one also checks, so it works. We have the correct solution. Alright, it says, solve the system of equations by substitution. Check your answer. On these, I have x and y on the same side and x and y on the same side. You should have known that was going to happen to you. So we have to look at them and see which one is going to be easiest for us to get x or y by itself. And I always like to choose one where the x or the y has a coefficient of 1, because that means that there's no 2, 4, negative, 5, anything in front of it. So all I have to do is subtract something. And in this case, this one is where y has the understood coefficient of 1. So I'm going to use this one. So I have 2x plus y equals negative 6. To get y by itself here, I'm going to subtract 2x from both sides. So I have y equals negative 2x minus 6. Now I have an equation that has y all by itself. So I'm going to take this expression that y is equal to, and I'm going to plug it in over here. So I have 3x plus 2. Instead of y, I'm going to put negative 2x minus 6. And that has to be equal to negative 10. Now to simplify this, I'm going to take this positive 2 and I'm going to distribute it to everything inside those parentheses. So I have 3x, 2 times negative 2x gives me negative 4x, 2 times negative 6 gives me negative 12, equals a negative 10. So now I can simplify. I have 3x and negative 4x as like terms, which is going to give me negative x minus 12 equals negative 10. Now I need to add 12 to both sides. I have negative x equals negative 10 plus 12 gives me a positive 2. But I don't want to know negative x, I want to know x. The negative is an understood negative 1, so I'm going to divide by negative 1 on both sides, which is going to give me x is equal to negative 2, which I'm going to take and I'm going to plug in to my original equation. So I'm going to plug it into the top one. I have 2, instead of x I'm going to put negative 2 plus y equals negative 6. So 2 times negative 2 gives me negative 4 plus y equals negative 6. Now I have to add 4 to both sides. So I have that y is equal to negative 2. So my solution is negative 2, negative 2. I'm going to check it by checking it with the second equation. So I have 3, instead of x I'm going to put negative 2, plus 2, instead of y I will put negative 2, equals negative 10. This gets me a negative 6 plus negative 4 equals negative 10. Opposite signs gives me a negative, so negative 6 minus 4 gives me negative 10 equals negative 10. It checks. So this is my solution. Alright, the next one, we are doing the same thing here. So this time, however, we are stuck with coefficients for both of them. So we're going to have to do something a little bit different to make it work, and that is not necessarily do something different, but we're going to have to solve a little further before we can substitute. So on this one, for example, if I have 2x minus 3y equals 8, and I add 3y to both sides of the equation, I will see that these are going to cancel, so I have 2x equals 3y plus 8. Now I need to divide by 2 on both sides to get x by itself. So I have that x is equal, and remember when we divide on each side, the 2 has to go to everything. So I have 3 over 2y plus 8 over 2, which is 4. And then I can take this expression and plug it in for x in the other one. Okay, I just did that to show you it doesn't matter which variable you have by itself, we can still get the correct answer. So as long as you get one variable by itself, it doesn't matter if it's x or y, it'll still work. So I have 3, instead of x, I'm going to put 3 over 2y plus 4 plus 4y equals a negative 5. And when I distribute my 3, this is a fraction, so I have 3 over 1. 3 over 1 times 3 over 2 gives me 9 over 2y plus, not 4, plus 12. Let me fix that. Oops. Plus 12 plus 4y equals negative 5. And now what we're going to do is we have to add these two things together. So I can do that either by changing this to a decimal or by changing this to a fraction. And I'm just going to change this to a decimal because I know how much you guys love to work with fractions. So if I take 9 divided by 2, I get 4.5y plus 12 plus 4y equals negative 5. Whoops, I forgot the 4. So now I have like terms. 4.5y plus 4y gets me 8.5y plus 12 equals negative 5. So I have to subtract 12 from both sides, which is, whoops, I'm running out of room here. So I have 8.5y is equal to, because those canceled, negative 5 minus 12 gives me a negative 17. Divide by 8.5 on both sides of the equal sign, and I get that y is equal to negative 2. Well, if y is equal to negative 2, I can take that and I can plug it in to this one, or to the top one. Let's plug it into the top one. I have 2x minus 3, and y was equal to negative 2 equals 8. So 2x, negative 3 times 2, negative 2, gives me a positive 6 equals 8. And the positive 6 I have to subtract from both sides, so that will cancel. I have 2x equals 2. To get x by itself, I need to divide by 2 on both sides, which means that x is equal to 1. So my solution to the system is 1, 2. And I want you to check it on your own. So you plug in that solution of 1, 2, or 1, negative 2, excuse me, 1, negative 2 to both equations above and make sure that they work. A school play charges $8 for adult tickets and $5 for student tickets. 75 people attended and $444 were collected. How many adults attended and how many students attended? So what we have to do is we have to write our own two equations to be able to figure this out. So the first one I'm going to start with is about the dollar amounts. I know that it was $8 for an adult, $5 for a student, and that $444 were collected. So I'm going to represent this by saying 8A, meaning $8 for every adult, plus 5S, meaning $5 per student, equals however many adults and students there were, whatever they were charged has to equal the total that was collected, that $444. Then I have that there were 75 people who attended. So if there were 75 people, some of them were students and some of them were adults, I know that the adults plus the students has to equal 75. So now I have my two equations, and I have two variables. They're the same. I'm going to solve one of these to get one of the variables by itself. This one looks easier to me, so I'm going to subtract s from both sides. Those will cancel. I have a equals 75 minus s, which I'm going to take this and I'm going to plug it in over here for a. What I want you to do at this point is I want you to solve the rest of this by yourself. You should be able to tell me how many adults and how many students attended the play. So on your own paper, that's all I have for you. Please take good notes. Make sure you've taken good notes, and I will see you in class tomorrow. Have a good night.